We're going to continue our study on exponential functions, and when we come to 7.3, we're going to see the title has nothing to do with an exponent. It says logarithmic functions as inverses. But since chapter 7 is about exponents, we have to talk about logarithms, okay? Because logarithms are the inverse of exponents. So even though the word exponents isn't in the title, it technically is, because a logarithm is an exponent. Move down, and let's talk about what a logarithm is and how you can write a logarithms. Let's read this essential understanding. The exponential function, y equals b to the x, is 1 to 1, meaning it's a function, everybody. So its inverse, x equals b to the y, is also a function, a 1 to 1. To express y as a function of x for the inverse, you have to write it as a log. Now I know that's a lot of writing and words to you, but let me go ahead and try my best to explain it just kind of in basic words. A logarithm helps us to find the value of a variable when the variable is an exponent. And this is one of those what I call one of those essential understandings, the big question, the big ideas. We're going to do this with the principal and interest problems. We were used to doing this with principal and interest problems, and we used to guess and check. Like, for example, I would say, when would such an amount, like when would $500 turn into $520? And you'd have to use guess and check. But a logarithm is going to help you get exact answers right away. And so, without knowing it, you see logarithms all around. You see them in earthquakes, you see them whenever you turn up your stereo in your car, and we'll talk about that as we move along. So the main idea is, when should you use a logarithm? You should use a logarithm when solving for an exponent. Today's lesson is going to start easy, and it will increase in difficulty as we move along. There's a key concept box at the top, and this is a logarithm with a base of b of a positive number x satisfies the following condition or definition. As long as b is bigger than 0 and b is not 1, the log with a base of b of x is y. If and only if b to the y is x. Now that's a lot of writing. So I have the big question, what does all of this mean? I want to practice, okay, let's write this down. Let's practice going between forms. And that's really going to help you understand this box up here. Now let's pretend that I give you something like, you ready? Pretend I say 3 to the 4th is 81. I do hope you agree with this. This is called exponential form. You should be very familiar with exponential form. Now, how can we write this in logarithmic form? Well, your base is a 3. So we write the word log, which stands for logarithm, and that base, our base of 3, goes right here. And we write it real small next to the log to indicate that it's a base. Maybe we should point to that and say base. Okay, log base 3 of 81 is 4. Can you see how the answer is the exponent? That's because logarithms are exponents. Let's write that down. Logarithms are exponents. Let's try again. Pretend I gave you something in logarithmic form. Let's say I gave you log base 10 of 1,000. I wonder if you would be able to tell me what that's equal to. Well, here's your question. 10 to what power is 1,000? 10 to the 3rd power is 1,000. This is logarithmic form. Let's talk about exponential form. Your base is 10. It's to the 3rd power, and it would equal 1,000. So these are the exact same things in different forms. Problem 1, we're going to practice this a little bit more. What is the logarithmic form of each equation? Well, this one we start with log. It's log base of, where's your base? 10 of 100 is 2. Notice how your base goes beside the log to indicate what base you're working in. Your exponent is the answer, and what you're trying to get to, that's the big one right there. Let's rewrite part B. Take a moment and try it yourself. You should write log base of 3 of 81 is 4. And you can notice that's actually the example I did above. Let's try the got it. This one is log base of 6 of 36 is 2. So we're saying 6 to the second power makes 36. This one is log base of 2/3 of 8 over 27 is an exponent of 3. Okay, let's go to part C. Log base of 3 of 1 equals 0. And that is because 3 to the 0 power is 1. Alright, now when a question asks what is the log of, and they give you something, they're really asking what is the exponent that gives me this answer? So let's look at log base 8 of 32. They're really asking this question. So they are really asking 8 raised to what power is 32? Now, I know I can go to my calculator, right? And I can do 8 to the first power, but we all know 8 to the first power isn't 32, and we know 8 squared is 64. So how does 32 fit into this picture? Well, what we want to do are the following steps. Step 1. Get a common base. Get a common base. Step 2. Set the exponents equal. Now what you need to be able to know, guys, are your bases. Alright? Can you think of anything that becomes an 8 that could also become a 32 when taken to a certain power? Like, for example, could you do I know I could do this one, 2 to the 5th. What about 8? Is there anything you can do with 8? Could you make it 2 to the 3rd? But don't forget, there was already an x up there. So I hope you agree that 8 is really 2 to the 3rd, but there was an x, and that 2 to the 5th is really 32. Now I struggle with this sometimes with students is they think the 2's technically cancel out. The 2's don't really cancel out, but if that's how you need to see it, that's fine. We're going to take our two exponents now, since we have the same base, and we're going to set our exponents equal. 3x equal to 5. We're going to divide by 3, and x is 5/3. Now if you're ever questioning if you did this right, get your calculator, do 8 to the 5/3, and you can see you get your answer of 32. Let's try this again. On part A, they're really asking 5 raised to what power is 125? Well, the common base is 5, and I know this over here would be 5 to the 3rd power, because 5 times 5 times 5 is 125. I set my exponents equal, and I solve. X has to be 3. Let's go to part B. 4 to what power is 32? Now, can you think of 32 being like a 4 to the power? Please do not think that 4 to the 8th is 32, because it's actually 4 times 8 that makes 32. Instead, you need to think of bases. What is a base of 4 that's also a base of 32? 4 is 2 squared, but it has an x, and 32 is 2 to the 5th. Set your exponents equal and divide. If you're not sure if you did it right, grab your calculator. This one's a little more difficult. And do 4 to the 5 over 2, and you get your answer of 32. Try the next one. This one steps it up a level because this one's a fraction. And you will realize why we had to study negative exponents. So in this one we're asking 64 raised to what power is 1 over 32. Now watch how I handle this. I'm going to put a star because this is going to be a difficult step for some. And I'm going to make that 32 to the negative 1 power because that's what fractions are. Anytime you want to move something, you make it to the negative power. Well, I know that 64 could be 8 squared, but 32 doesn't have a base of 8. They do both have a base of 2, so let's try to think of this. 2 times 2, how many times would you have to take 2 to get to 64? I do believe it's 2 to the 5th power. Nope, 2 to the, 6th power. So what I'm going to do is I'm going to make this 2 to the 6th, and over here, I know that 2 to the 5th is 32. But because of the negative sign, that drops down in front of the 5. So I set my, this has an x, the 6 has an x, because it was up here. Set my exponents equal, divide, and to play it safe, let's check it in your calculator. 64 to the negative 5 over 6 is 1 over 32. In the next video, we're going to talk about this concept called the common log. And this common log is what you see all around you, almost in everyday life.